First, about the selective structure of C language, that is the conditional statement. Conditional statement, and we have seen the main conditional statement, that is if else, then simple conditional statement where having only if or having one if and its corresponding else. Then we have seen the nested if else. The flowchart may be like this. So this is a condition. If it is true, it will go into this side. Then another condition here. Okay. If it is false, then there may be another condition. So this type of, so I have used one conditional statement here. Inside the if part, again I am using another conditional statement. In the else part, I am using another conditional statement. So I can say this is nested if else statement. Similarly, there may be multiple conditional statements. It depends according to your problem. You may need some multiple conditional statements. The multiple conditional statement flowchart will be like this. This is your condition. So if it is true, it will do something. If it is false, then it will go for another condition checking. For true, it will print this one. If false, again it will go for another conditional statement. So this is for true and this is for false. If false, it will go into this side. This is for true, this is for false. Again, there is a true part and similarly a false part. So this type of thing is called multiple conditional statements. In that case, you have to write your if else like this. If condition, then if true, then this one, else. See, this is the else part. In the else part, again I am using another if. So this is if. So else, again we are checking another if statement. If it is true, it will do this part. Else, again another if condition. So this is called multiple conditional statements. Okay, it means there are many different criteria that you have to satisfy, such as one particular example, that if your marks is greater than equal to 90, you will be awarded with O. If your marks is less than 80, greater than 80, if your marks greater than 80 and less than say 70, so means I'm just trying to giving you the idea that if there are multiple different conditions are there, then how to satisfy. In those cases, you have to go for this multiple conditional statements. Okay. Now, there is another way you can solve this multiple conditional statements, that is using switch case. Using switch case. So switch case is another alternative for multiple conditional statements. Statements. This is another alternative. Okay. Now the syntax of switch case is almost like a function. It is almost like look like a function. Why? Because if you see, the syntax is like this. In the switch keyword, you have to pass one variable that will be checked. The value of the variable will be checked. So suppose, for example, let us assume the example of marks. If your marks is greater than equal to 90, you will be awarded with grade O. And if your marks is greater than say 80 but less than say 90, or you can say less than equal to 89, then you will be awarded with E. Similarly, if your marks greater than 70, okay, and within 79, less than equal to 79, you will be awarded with A. So the variable which you are going to check for multiple times is this marks. So in this switch variable, this variable is your marks. You have to pass to check this variable, and inside the this switch you will check different case values. Case, say one particular value. If so, let say this one, say case a constant value. Normally we use constant values. Suppose the constant value, I'm writing constant integer value. Remember this, it will be always constant integer value. Case constant integer value colon, then you will do some statement, some operations, okay, and then comes the next case. Case again another constant integer value. You will do this thing. Okay. In this way, you have to write your switch and case statements. So this is your switch, and these are the different case. If your case matched, if your variable value matched with this value, then this part will be executed. So suppose how to write this mark statements in your if else. So if marks, suppose I'm writing, suppose marks greater than say 40, say 40, and marks less than equal to 49, you will be awarded, suppose this is for D. Okay. Else, if your marks greater than 50 and marks less than equal to 59, so it should be greater than equal to, okay, because here up to 49, so here comes 50, so 50, so this equal to, then you will be awarded say C. Similarly, the next else if, so you will write it, this multiple conditional statements, you will write it in this form. Now if I want to replace this with a switch case, how can I do this? Okay. Before that, how I can solve this, before that you have to understand that in case of switch case, I have already told you that in case of switch case, there should be some constant integer value that will be checked. Okay, and this variable must be either integer or character. No float values are allowed. I hope you can remember why not float values are allowed. We have seen in the last class one particular example, that suppose float x equal to 0.4 already assigned, okay, and then I'm trying to check if x equal to 0.4, okay. Here the printf statement, yes, and there the printf statement, no. And I have shown you that the output, very interestingly, the output is not yes, it should be no. But if the value, suppose the value of float here x, instead of 0.4, if it is 0.5, and you will write if x equal to 0.5, printf yes, else printf no. In that case, in this particular value, you will get yes. But for 0.4, you will get no. So it means in case of float values, it is not always, means you are not correctly assigned what should be the output. That's why in case of switch case, we don't use float variables. And remember, this value, this case value, always must be constant integer value. You cannot use any variable here. I'm going to that. Before that, can you tell me why this is happening? What is the reason for this? Why in case of float values, this type of thing is happening? Anyone? Any idea? Why for 0.5 it is giving yes, although, but in case of 0.4 it is giving no. Anyone? Ayush? Nitish?
Yes, sir.
বলতে পারবে কেন এটা হচ্ছে? Any idea?
So ওটা তো স্যার ইয়েস হওয়ার কথা না স্যার?
আমি আগের দিন দেখিয়েছিলাম, মনে আছে তো?
কনভার্জনের জন্য 0.4
আগের দিন ক্লাস করেছিল তো? আগের দিন দেখিয়েছিলাম না?
হ্যাঁ স্যার।
তাহলে আমার ভিডিওটা দেখে নিতে হতো। আগের দিন আমি দেখিয়েছিলাম যে 0.4 এটা যদি আমি অলরেডি x এর মধ্যে অ্যাসাইন করে রাখি, তারপরে যদি আমি বলি x is x equal to 0.4, it will give me no. হ্যাঁ, আরেকজন কে বলছিল একটু বলো, what is the reason? Okay, see how to convert one integer value into binary. To convert one integer value into binary, I have to perform this division operation, okay? But if it is a float number, how to convert it into binary? In that case, I have to multiply it with 2, okay? So if you see for 0.4, what is happening? So it is giving us 0, and it becomes 0.8. Then 2, if I multiply, the integer part is 1 and the fraction part is 6. If I again multiply, it will give me 1 and this fraction part is 2.2. Then again 0 and 0.4. So see, after some iteration of converting it into binary, I am again getting the same value from where I have started. Again I am getting 0.4. So it means the binary conversion of 0.4 is infinite. It will go infinite. Logic clear? But my float variable having some limit of bits. Suppose, let us consider that my float variable only can store, say, 5 values, 5 integer bits, 5 bits. So I have stored 0, then 1, so this bits, then 1, then 0, then again I will get a 0. So then there are 1, 1, 0, 0, 1, 1. So it is infinite. But since my float variable has a limited size, it has a size, say, 5 bits, it can only store 5 bits. So after sometimes what I have to do, I have to truncate. I have to truncate this. So I am just deleting this part. I am only storing this one. Okay. So x, variable x, which I have defined, float x equal to 0.4. So this is my x. Okay. And what is the original 0.4? So this is the stored 0.4 in x. But what is the original 0.4? The original 0.4 will be like this. Will be like this, infinite. Continue. So which one is greater? This one, original 0.4, or the stored x 0.4. Which one is greater? Obviously this one is greater, because in this case I am deleting some portion. It means it becomes, deleting means it becomes 0, all 0. But in this case, after this, it is having some bits. It means this 0.4 is greater than x. But if I do this like this, I am assigning two variables x and y with same value. And if I write if x equal to y, what is the output? It will give us yes. Because in this case, both this xy are stored with some limited bit size. So both having same data sequence, both having the truncated part 0. But when I am comparing a stored value x with a original value 0.4, now this original 0.4 having infinite sequence, but I am truncating my stored x after some time. So the stored x having bit value like this, 0 0 0 0, like this, but the original x value, sorry, original 0.4 is like this. Am I clear? Am I clear? So which one is greater?
Yes,
Obviously this one is greater. But what is happening in case of 0.5? 0.5 is not giving us infinite series. See, it becomes 0 after one iteration. The fraction part becomes 0. So I will stop here. So for 0.5, whether it is stored in x or it is original 0.5, both having same bit sequence. Let us check. Let us check. I'm telling much things. If I don't show you, it will not be clear. File. Just simple code is int main, then float x equal to 0.4, and then cl-6.1, this one, then if x equal to 0.4, then printf yes, else printf no, then the get ch and then the return 0. Okay, so let's save it, save as this is online coding class. Say already this 3, so code and C. Oh, it's already 1.4. Okay, so alt compile. Now, so in this case, if I run, no. Okay. Now see, if I instead of 4, if I use 5, both the cases 5, then yes. Okay. Why in case of 5 or suppose in case of 0.25? Both are not infinite. Both are not infinite. So in both these cases, I will get yes. But if it is say 0.2, if it is 0.2, not 0.5, 0.2, if it is 0.2, then again you will get, because 0.2, 0.4, 0.3, 0.6, 0.7 all are infinite sequence. It will give us binary infinite sequence, and since I have a variable x which is having a fixed size, so after some time I have to truncate. Truncate means I am making those parts 0. So see, very interesting. If I write here, it is in this form, this one, it means x is less than 0.2. Now see what it is giving. Okay. Now if I write x greater than, is it clear what is happening? Why it is giving yes? So this truncation is very important. How I am truncating? This truncation is very important. Sometimes we truncate if the last bit, see for 0.4, for 0.4, for 0.4, should be 0.4, should be greater than this, but it is giving no, means x is greater than this. X. Now if I use y equal to 0.4, and then if I check the value of x and y, what will happen? I think I'm making some mistake. Why it is giving? Should give yes. Why it is giving no? Should not give no. Okay, should give yes, because in this case x and y both having same value, and I am truncating, so it will give me the same value. But when I am comparing it with one variable with some constant value, then normally this should give is x must be less than 0.4, because in case of x I am making the truncated part 0, but in 0.4 it is still having some part, so this should be give yes. Why not giving? Just why not giving? Sometimes compiler also have some strange thing. What is giving yes? It should give yes. Okay, it may be due to some compiler problem, but it should give yes. For this, it should give yes. Okay, so I hope now it is clear why this thing is happening. Why I am getting, in case of float variables, why it is not possible to compare one constant value with some variable. And that's why in case of switch case, we don't use any kind of float, only integer and character. Okay, another thing that you should remember, in case of case value, the case value should be one constant integer value, no variables. What does it mean? No variables. What does it mean? It means, suppose I have one variable, say integer variable ch, that I am going to check in the switch case. Okay, so I'm passing it in the switch case. Then the case values, normally the case value should have constant integer like this 5, if this one is matched. So case 5 colon, then I will print say 5. Okay, if case value say 4, I will print 4. So this way. Okay, so now suppose instead of 5 I want to write it like this. Suppose I have one integer variable with value 5, and I want to write here, instead of 5 I want to write here x. But remember, this is not allowed. Not allowed. This is wrong. It will give you error. In this point, it will give you error. It always must be some constant integer value. Constant integer value. That is very important. And we can use character variable also. Character A. Why character variable? Because character variables also have some ASCII value, which is again constant integer value. So remember this, no float values, no variables are allowed in case, only constant integer values. So if I want to convert this one, that the given marks, and according to that given marks I want to print my grade value, that is OEA, like this, then how to write it? See, one interesting thing that uh, from your marks, total marks, suppose your total marks after percentage, not total marks, after percentage, it is giving you say from 80 to 89. If it is from 80 to 89, you know it is E. If it is 70 to 79, it is A. If it is 60 to 69, it is B. If it is 50 to 59, it is C. Similarly, if it is 90 to 100 or 99, it is O. Correct? So, how can I check it? How can I use it in our switch case? Because in case of switch case, since it is a range of values, in case of switch case, we cannot check range of values. In case of switch case, only we can use a single constant value. So see, the interesting thing, in this 90 to 99, what is the 10th position value? 10th position value is 9. What is for grade E? The 10th position value is 8. What is in grade A? The 10th position value is 7. Okay? It means if I perform a division operation for my marks, so how I can check it? Switch. So before switch, what I am doing, suppose M is equal to marks divided by 10. It means If my marks is from 80 to 89, if I divided them by 10, it will give me 8. For 80, it will give me 8. For 89, it will give me 8. Why? Because this is integer division. Marks is integer divisions. I am performing integer division. Marks is integer variable. So this is integer division. So it will give me only the integer part. So M always give us some integer value, either 8 or 7 like this. So now I can pass it into my switch case like this. Then I can check it like this. If case value is 9, then I will print my grade is O. Okay. Then case value 8, then I will print E. Similarly, in this way, I will write the other cases. Now, in case of switch case, if no case is matched, there is one case which is called default. Default case. Default case means if your M variable not matched with any of the case value, then which one will be satisfied? Then it will satisfy the default case. This is already given in the syntax of switch case. So this is called the default case. Okay. Now, in case of switch case, there is another interesting thing that you have to follow. That is, you have to give some interruption. Okay. Interruption means you are giving some interruption by using break statement. Okay. This break statement normally used in case of loop to terminate or interrupt a particular loop after some condition. But in case of switch case, you also have to use some break statement. Otherwise what happened? Suppose your M value matched with 9. So this is the entry point for the switch case. And after printing O, it will print all the values. It will print all the values. So that's why you have to give some break interruption so that it can come out from the switch case. Okay. So in case of switch case, what are the things you have to remember? You have to remember it should be either integer or character. The variable that you are going to check, it must be either integer or character. The case values must be constant integer, no variables are allowed, only constant integer values. Since character, constant character or character having some ASCII value, so this characters also allowed in case of case values. Okay. Then there is one default case. Okay, there is one default case. If your case value is not matched, then which one? So this default case you can say is the last else. If you are writing nested multiple if else like this, then the last else is the default. This default is the last else. Okay. And then another thing you have to remember, you have to use one break statement to interrupt or terminate your case value. Otherwise, if switch case get any entry point for any case value, it will try to satisfy other case values also. That is one drawback in case of switch case. Okay. So you have to take care of this thing also. So whenever you are writing your switch case, you have to remember all those things. Next,
Sir,
very interesting.
After default value also we have to use break.
No need to give break after the default value, but there is one but. Suppose you have written, see this case value you can write in random order. There is no particular order for case values. Suppose your case values, you are thinking that case values should start from 9, then 8, then 7, then 6. You can give them in any order. Suppose case value 5 first, then the case value 9, then the case value say 8. There is no particular order is maintained in case of switch case. Okay, even you can use, normally the default should be the last statement. but you can use your default as first statement also. Suppose you have written your default at the top. Okay, is it clear? Then in that case, you should use one break statement in default. Am I clear?
Yes.
Is it okay? So normally there is no particular order of case values or default case values. You can write it in any order. Normally, if we write the default case at the end, then no need for any break statement. But if we write the default at the top, since there is no particular order, then you should use one break statement in that default case. Okay. Otherwise, normally for default case, no need for any break statement, because this is the normally this is the last statement. So we can exit from there. But if we use default at any intermediate step, intermediate position or at the top position, then you should use one break statement after the default. Okay. So this is your switch case. Using switch case, you can easily replace the multiple if else, which is a little bit you can say time consuming, and you have to write so many things, if else. So better you can go for switch case. But remember, if it is a float value, then it is very difficult. And if there is a range of values, suppose your multiple if else statement is like this. If suppose if your weight is greater than 15 and less than 25, then you will be awarded as lightweight. Okay. If your weight is greater than 25 and less than 35, it is a middleweight. Now see, there is no, this is a range of values which is not actually converted in single value. If you are able to convert this range of values in a single value, then you can go for switch case. Just like our grade, where the range is from 80 to 89, but I can convert it into one single value by performing a division operation by 10. I will get 8. Whether it is 80 or 85 or 89, I will get 8. So if my if somehow I am able to convert some range values into a single value, then I can go for switch case. It will minimize my my time. It will minimize